So the next step we're going to do, and this is going to seem like an almost seemingly equally pointless exercise, is we're going to create another class, which I'll call SList, with 2 L's. And this class is going to represent, let's see, this is an SList is a list of integers, which hides the terrible truth of the nakedness within. All right. And how this list is going to work is, well, we already have a perfectly good int list class, right? I mean, it's called int node now. So I'm going to make one called, I'm going to make a variable in SList called public, I'm going to declare a variable in SList, so it'll be public int node first. And then I'll have a constructor for SList, public SList int x, first equals new int node x null. And at that point, once I've written this class, I can do something like SList L equals new SList 10. And what this code does is creates a list of one integer, namely 10. All right. So what's good about this? Why have we done this seemingly pointless exercise in bureaucracy? Well, this is a little bit of a clue. If you think about how I, some programmer, have created a list, I did not have to actually specify a null, right? An SList does not have that property. You just give it an X, and that's it. So if we compare the old way of doing things, int list to int nodes, we can look at the declaration of a new naked recursive list, looks something like this, and a new hiding the nakedness from the world list. Okay? So int node, in this case, we see that we have to specify the address manually. Now that's also a pretty minor improvement, right? But it gives us a sense of where we're going with this, right? The programmer who's using an SLList, they need not think about references. They don't have to specify the null. And that same property is going to recur as we build up our other methods. There'll be no need to even be thinking about any of this naked recursion.